Great. So before we start, just a quick introduction. Canopy Power is a Singapore-based renewable energy microgrid company, and we generally focus on the projects where the customers want to make an energy transition. So there are thousands of businesses and communities, especially here in Southeast Asia, who have two problems: energy access and energy security. And the reason is because they don't have access to the reliable grid. They are connected to a poor grid, or sometimes they are remotely located, so they have to generate electricity using diesel, which, as you can imagine, is very expensive, it's unreliable. So we help these customers to make the energy transition by hybridizing their existing assets. In many cases, these are diesel assets. So we will add renewable energy sources, whatever makes sense on that site. In many places, we add ESS, energy storage, batteries, then smart control, and help them to make a transition towards cheaper, cleaner, reliable power grid. There are three principles behind our work. One is decarbonization. That's where renewable energy comes from. Then digitalization. We'll talk a little bit about our technology and how we digitalize these assets, these microgrids later today. And we financially de-risk the projects for our customers by providing critical financing, which is required at the start of the project, which is very important for several customers. We'll talk about that too. Today, Canopy Power is active in 7 countries. Out of that, in 4 countries, we have operating or under construction assets like Indonesia, Malaysia, Myanmar, Cambodia. We are in business for 4 years, and over this time, by doing these several projects, we have collected a lot of experience, and many times we learned hard way. So we thought, let's have this webinar so that we can share this knowledge and experience, these experiences with you today. The main focus obviously is going to be how to flatten the energy cost curve using renewable energy microgrids. So over to Daniel to share this knowledge and experience with you.
Okay, thank you, Sujay. I hope everybody can hear me. Give me a shout if you can't on the chat. I'm Daniel Rye. Welcome everybody, and thank you for joining. I hope you're all well in these interesting times. Without further ado, let's get going. We'll start with a quick agenda of what we're going to run through today. So we're going to be focusing on minimizing energy costs for businesses in remote areas. Okay, so we'll first off frame the problem by looking at what we call the remote power trilemma. We'll then look at a possible solution, the renewable energy microgrid. Can it solve the trilemma? And then we'll look at the practical aspects of implementing a renewable energy microgrid, and we'll be focusing on the 3 keys that are surrounding that from our experience. And we'll have a quick look at where Canopy Power comes in, what our solutions are. We'll look at one of our case studies next, and then we'll have a Q&A where everybody can ask a question, either audio or over the chat. So let's get going. What is this mysterious remote power trilemma, and why does it matter? Let's find out. So the idea behind this trilemma is that there are 3 desirable factors that every business wants to fulfill, but typically we can only satisfy 1 or 2 of them in any given place. So this trilemma is represented by a triangle with 3 apexes, and each apex is one of those factors. So the first factor is energy security. So energy security, basically, what is the combined trustworthiness of the companies, the third parties, and the resilience of the equipment that brings the fuel or the electrons to your business site. Second one is affordability. So this is obvious. It's basically what is the total cost per kilowatt hour. But remember that we really focus on long-term costs. We're not just talking about on a daily apparent kilowatt hour cost level. We're talking about long-term costs. And the third is stability. So stability refers to what percentage of the time the power system is supplying electricity to the loads within the margins of acceptable power quality, be it voltage, frequency. And if you're not optimizing all of these things, you're definitely taking a hit on your P&L. And that might be avoidable. So you need to look at what you can do to avoid some of this cost and some of this revenue hit as well. So let's go through these factors in a bit more detail. We'll look at some common scenarios, see how this trilemma can be fixed in each of those scenarios. So firstly, energy security. We'll just look at an example. It's a project that we're currently designing. It's in Cambodia and it's an island. And the solution we're bringing to the island is for a whole bay where there's like 50 hotels and resorts. But currently, each of those hotels and resorts, they bring their diesel in individually. Each resort brings it in individually in these canisters that you can see here in these photos. And they each have their own diesel generator, and they each supply power to themselves through their own generator. So as you can imagine, there are many potential points of failure in this supply chain, as even without Mother Nature intervening. So the antidote to this is obviously a solution where you don't have to rely on any third parties to bring your fuel to site. And ideally, it would be a free fuel, which is delivered to your site by nature, for example, solar energy. And the higher proportion of your RE generation, renewable energy generation, the higher your energy security, by definition. So that's the first factor of the trilemma. The second is affordability, and that's our main focus of today. So right now, in Southeast Asia, we have 8 billion kilowatt hours generated annually from diesel generators. That's 2.5 to 3 billion liters per year. So let's look at the two applications where this is happening. Firstly, it's in the edge of grids, where you're connected to a grid, but the grid basically is a supply that you can't rely on for business critical operations. So you have to have a backup, and it has to be a long duration backup. And typically that's a diesel generator. So you need to have a diesel generator on site. You need to have a large fuel tank to last at least 3-4 days of operation for the worst blackouts. So your costs are dominated by things like the one-time grid connection. So when you set up your site, typically you'd have to pay a grid to actually build the last mile to bring the grid to your actual factory or commercial unit. That's going to be a one-time fixed cost. Then you've got your demand charge, which is your maximum draw per month. Then you've got the actual kilowatt hours that you consume each month from the grid. And then you've got the backup power costs, which is buying diesel generator, buying the fuel, and keeping everything ready to go at all times. The other main scenario is where most of the 8 billion kilowatt hours are generated, and that's in off-grid. Places like in Indonesia and the Philippines, where you've got thousands of islands that aren't connected to any grids, and they're self-sufficient, so that they're self-generating electricity from diesel and relying on the outside supply of diesel into the islands. So the main cost here is dominated by fuel delivery costs, and fuel storage costs, and then generator system O&M on top of that. So we want to give an example of this. Recently, we went to a client's site in the Philippines and we did a site survey. And this is a typical thing we do, but this is a really good example to bring home the issues. So we measured their load. It was less than 400 kilowatts average. So average over 24 hours, less than 400. So it's not a huge resort, medium size. And this is their actual energy, so fuel spend. So here's the actual this year's spend in year 0. And assuming a 3% escalation, this is what their fuel spend will be in 25 years. So when you add the total 25 years fuel spend is 32.5 million US dollars. That's insane when you think about it. The thing is, businesses don't think about it like that. They think about the next month, the next year at best. But if we think about what we could save over 25 years, that's when we really value the alternative, which we'll be talking about. So you might think, isn't this just horses for courses? If you want to set up a shop in a remote location, maybe this is just one of the costs you have to bear, right? Well, not anymore, because solar PV has seen one of the greatest technology price declines ever seen. It's followed almost half of Moore's law trend, and we're now at a price 16 times lower than in 2008. Lithium batteries are starting to see a similar pattern. They might not be as fast, but there's a lot more price cuts to come in lithium battery costs. So all that means is that off-grid PV deployments, which is effectively dependent on solar plus battery, are starting to pick up. They're becoming commercially viable in more and more territories around Southeast Asia. When we look at the levelized cost of energy, we can see why this is happening. So comparing the levelized cost of energy, which is the cost of energy over 20 years, when all costs are considered, diesel system is, depending on which country you're in, between 20 and 40 cents, US dollar cents. So that really depends on the subsidies and the taxation that we have in the country. It's quite a big range. I would say probably 30 cents is what we see most of the time. Then we look at off-grid solar PV. LCOE at the moment for this is 8 to 12 cents, so significantly less. And then we add a battery into the mix, and the LCOE currently is now 17 to 22 cents, okay, per kilowatt hour. So we can see that solar plus battery is already cheaper than diesel in most cases. But one of the challenges we've had over the last 2 years, which we've been working on, is to fix how customers are able to move from a cost structure which is OPEX dominated, diesel generation, to a cost structure which is CAPEX dominated, which is renewable energy. With renewable energy, you're basically, every bit of equipment you buy, every solar panel is like buying your energy for the next 20 years, basically. You're paying for it all on day one. So we've got to find a way of moving that CAPEX model to something that customers are more comfortable with, that reflects an OPEX-like model. And that's what we do with imaginative kind of financing solutions that bridge this gap, which we'll talk about later. Okay, so that's affordability. And the final factor in this trilemma is stability, or power stability. So outages obviously lead to lost revenue for any business. For example, in a resort, if you've got poor power quality, this is going to inconvenience your customers, you're going to lose reputation, you're going to lose business as well. And also poor power quality, like voltage fluctuations, can also damage equipment. So sometimes you have to replace sensitive equipment if you have poor power quality, which is all things you want to avoid if possible. So what causes poor electrical stability? It can be design flaws, it can be a lack of O&M, and it can be like intrinsic things like distance from the main grid, the length of the line that you're using to connect to the grid, and things like that, and also environmental factors and disasters. Okay, so having covered the three trilemma factors, energy security, affordability, and stability, we're going to look at a couple of scenarios to see how this is the kind of like picture looks in each of those scenarios. So in edge of grid, where you're connected to a grid, but it's a long way and it's likely to be low reliability. Here you can see that you've got good affordability because you're actually you're benefiting from grid tariffs, which is always lower than generating from diesel. But you're expecting, and you probably experience frequent brownouts and some extended blackouts. So stability is extremely poor here. So when you're off grid with diesel generation, energy security is even worse, because you're not only reliant on an external company to supply fuel, more than one probably, but you're also exposed to the volatile energy markets. So the oil price, as you can see in the last 5 years, has been all over the place, and diesel prices effectively follow that. So your business planning goes out the window when you're exposed to all of that. In terms of affordability, it's more costly than the grid, so performance worse there as well. But from a stability point of view, if it's well designed and it's got good O&M, operational maintenance, likely it's going to be a very stable power supply. So that's the benefit of a diesel system. Then we can hybridize that diesel system with solar PV. Obviously brings down the fuel imports required, so that's better for energy security. Slightly more affordable because you're paying less for diesel. And security-wise, and the renewable energy, if you don't have a battery there, can cause intermittent problems for the diesel generators. So we say here that probably, unless you have a battery, your stability might be less in this case compared to a pure diesel generator scenario. So we've defined the kind of problem that we face in remote locations for energy. So now we're going to look at one possible solution, and that's the renewable energy microgrid. So why do microgrids matter? Firstly, we'll define it. It's very simple, not complicated whatsoever. A microgrid is a geographically localized electricity network. That's all it is, and it has to contain generation, energy storage, and loads, basically, and the distribution means to connect to the loads. So based on this, a diesel generator with a fuel tank powering a house is a microgrid. It has generation, it has a storage system, which is the fuel tank, and it has a load, which is the appliances in the house. So that's a microgrid. And in Southeast Asia, these microgrids, these kinds of microgrids, diesel only, take up 8 billion kilowatt hours of generation. So what we really want to do is we want to turn these kind of boring, costly, dirty microgrids into renewable energy microgrids. And we want to create something that can solve the trilemma that we just outlined, something that can satisfy all three factors. So who actually depends on these microgrids in Southeast Asia? As you can see, we typically see 6 main applications. Remote communities makes up the biggest volume. There's agriculture, there's fisheries, mining, and remote industries. But tourism is the sector where we see the biggest pickup in terms of adding renewable energy to their microgrid. They seem to have the biggest incentive to move forward at this stage. And we're expecting things like fisheries to be following that based on sustainability requirements. So a quick review of the types of microgrid. We've got the diesel-only microgrid, very simple. We've got the solar PV diesel microgrid, where we just add solar PV and the controller. And the controller makes sure that the diesel generator effectively is not damaged by the solar PV, so it throttles the solar if ever the diesel genset was going to go below a certain threshold. And then we have the full solar PV battery diesel microgrid, where energy storage is integrated. And this is really the one that solves most of the problems, and we're focusing on that solution. Okay, so how does it work? So in terms of the solar PV battery and diesel, just a quick introduction to how the operation works in different times of the day. So during the daytime, when it's sunny, the solar panels power the load, and the excess solar charges the battery. Okay. Then when the clouds come over, the the battery can immediately respond to any drop-off in the solar generation. And the reaction time for batteries is microseconds, milliseconds kind of time. So we have no impact at all of any intermittency here. Then late evening and tonight, the sun has gone and the battery typically provides the load for 4, 5, 6 hours into the evening until it reaches a certain depth of discharge, at which point the controller will turn on the diesel generator, and the diesel generator will supply the load for the remainder of the night until the sun comes up the next day. And then we repeat the cycle again. So this system solves the remote power trilemma effectively. We look at energy security. We've added excess solar generation. So we've gone above 50% in most cases. So that means our total reliance on delivered fuel drops below 50%. That's enough in most cases to power business critical loads through extended period of fuel supply interruptions if it ever happens. So energy security is satisfied. While it's not perfect, it's still satisfactory. Affordability. So with more than 50% of energy coming from free solar energy on site, again, diesel fuel cost is massively reduced, so affordability goes up. And stability, by integrating a battery storage system, we cover the RE, renewable energy intermittence. We cover diesel ramp rate deficiencies. And we basically turn the diesel generator off for many hours per day, which extends its lifetime. And the battery also adds system resilience because we've got another element in the system which can take the load on top of just the generator. So we've kind of appear to have solved the trilemma in theory, but how do we actually implement a long-term sustainable remote microgrid in practice? Again, we're going to look at another triangle. And this time it's IER. We have investment. This is the essential, one of the essential three things for a successful microgrid over time. Engineering and remote management. So we'll look at each of those quickly. So investment, there are three main ways of kind of financing a microgrid. Just with any other thing, the customer can buy it outright. If they've got cash, fine, do it. It's probably the best way. If they don't have cash, if they don't have $500,000 or 1 million lying around, there's the financing options, which can be a power purchase agreement, which is where the customer signs a long-term contract with the investor, and they agree to purchase at a certain rate kilowatt hours from the system for 20 years or 15 years. So the investor gets its money back, and the off-taker or the customer gets power at a lower rate than they would have got previously. So everyone's a winner. The other option is the lease finance. And this is the kind of finance that for our solutions, for microgrid solutions, really works well. So just to give you an example of how a lease financing works, we call it save to own. So this graph, it's the same graph as the previous resort that we saw, where their existing diesel generation fuel costs over time are in blue. And the orange graph, the orange bar chart, sorry, depicts the actual total cost of the lease. So the lease is roughly this portion. And then the 50% of diesel they still have to buy on top of the energy that's supplied by the renewable energy. So as you can see, from day one, the design of this financing is that they save from day one. So their total energy spend from day one is less than they would have had previously. Then after the lease is paid off after 10 years, they no longer have to pay any lease repayments. So all they're paying now is the 50% of diesel that they were paying. So obviously the step down of savings here is much bigger than it was once the lease is finished. So we call it save to own. They're saving immediately, and then they own the system after the lease ends, and the savings are even greater. So this solution is a solar PV battery diesel system, where the solar system and the battery is designed to provide 50% of all the energy over a year. Just a good example of how it works. Okay, so investment's the first one, and then the second part of building a sustainable microgrid is proper engineering. Okay, so engineering involves initially a lot of data collection from the site. Then we do a lot of number crunching, a lot of simulations to find the optimal solution. And getting this right from day one forms the basis of the overall design. So it's really essential stuff. So we use tools such as Helioscope, PVSys, and Homer Pro to do this. Secondly is system sizing, really essential. If we underestimate the load, for example, at this point, we'll have an oversized PV system. And that means suboptimal asset utilization. And that means a reduced IRR for the investor. So the investors we work with really value us for getting this right on the design stage. Thirdly, in engineering, it's probably something that might not be thought of often, but local environmental logistical considerations are key. So for example, this is kind of a joke, but taking a 40-foot battery container to a small island in the Maldives, it's not possible. That's not a solution. So we need another kind of battery solution. And things like salt levels in the air, humidity, rainfall, average temperatures, maximum wind loads, all of these things need to be taken into account for different aspects of the solution, the different components in the solution. And finally, we have the design and interoperability. So we're actually completely technology agnostic. So we don't have any favored technologies or any favored suppliers. For every project, we pick what's right for that project and what's within the budget of the customer or the financier. But interoperability is really key because there's usually 3 or 4 different elements that have some active control of the microgrid, and they all have to be able to talk to each other. They all have to be compatible. So we spend a lot of time making sure that we get that right at the design stage. And then the final key to a sustainable microgrid, in our experience, is having the right remote management platform. So the remote management platform firstly ensures that all generation and consumption is coordinated in the most efficient way at every instance. So that's a cost saving in itself. Secondly, the platform minimizes O&M spend. Firstly, because it allows remote management to solve most issues. And secondly, we allow intelligent data analytics to provide things like predictive maintenance, which further reduce costs over time. The third revenue stream that remote management platform can bring in, is things like enabling carbon credits and REC issuance, which we'll talk about more later. So that's kind of, in a nutshell, the 3 most important things in terms of implementing renewable energy microgrid. Now we'll just quickly show you where Canopy Power comes into this, and just wrapping up this whole model that we've discussed. So firstly, we solved the trilemma using a renewable energy microgrid with energy storage. Okay, so we maximize on-site fuel consumption or renewable energy. We achieved affordability by minimizing long-term costs and using finance to match to a traditional OPEX model. And thirdly, stability by utilizing energy storage technology and increasing power quality, resilience, and diversity. And in terms of implementing this, we have investment, quality engineering, and the right remote management platform. And if there's anyone out there who hasn't already worked out what that means, it means easier microgrids. So if there's anything that you remember from this seminar, make sure it's the easier part, and know how each letter basically represents how Canopy Power can help implement easier microgrids for customers. So for the next part, I'll pass you over to Sujay again, and he'll talk a bit about how Canopy Power implements the IER, the ER bit.
Great. Thank you, Daniel. So you saw that easier microgrids with Canopy Power. It does take time to come up with catchier names like this. So we spent like 2 days to make it easier. Okay, so I'm going to touch base on certain things we do, but I already got some questions in Q&A to talk about what are our offerings. Very simple. There are two offerings, two main offerings. One is solutions to build optimal microgrid, and second one is solution to ensure the microgrid runs optimally for next 20-25 years. Okay, so within the solutions to build the microgrid, the first one, which is very important, is investment. Yeah, we understand that there is a difference between buying a $20,000 diesel genset versus building a $250,000 microgrid, and sometimes it's more. 2050 is on the lower side. So what we have done is we have come up with certain financing solutions. Daniel talked about the save to own, that type of model. Also PPA, the oldest model in energy industry, power purchase agreements, we have that. The idea is there will be minimum capex for the customer. It can be anything between 0 to 20%. That's the down payment. And after that, they pay over time. And we can design the payment structure in such a way that you can save from day one. Yeah. This type of arrangements are already available into grid connected solar and wind and all that. What we are doing is we are bringing it to microgrid segment. So we have partnership with the Swiss Renewable Energy Fund. We have a JV with them, and through that we provide these solutions. It's an uncomplicated process. As I said, there are several flexible solutions because certain solutions which are allowed in Indonesia may not work in Philippines, and so you have to change that. And obviously there is a verifiable impact for which we use our technology. So investment is the important one. The next one is engineering, which is the core of Canopy Power. Yeah. So in engineering, we lost the slide. Okay. The next slide is we provide turnkey solutions. So everything from project development till commissioning and beyond. So A to Z. You just need to call us, and we will do development, design, sourcing, construction. But in some cases, some customers come to us, and many times these are the large EPC companies or developers. They say that I just want help with, say, project development or system design, or help me with commissioning. So we also provide those engineering modules under engineering services. So investments and these turnkey solutions, as well as engineering services, that goes under the solutions we provide towards building the optimal microgrid. And under this, as I said before, we have projects in Indonesia, Malaysia, Myanmar, Cambodia. We have pipeline coming from these countries, plus Maldives and Philippines. The theme is most of these places we are working with customers who are remotely located, so helping them with the energy transition by hybridization. So that's for the first two. The third part, which is very important, the second part of our offering is ability to ensure that we can remotely monitor and manage these microgrids. Yeah. So here is the list of the projects we have. I just touch base upon that. So there are several of them. The biggest one right now under construction is 1.25 megawatt solar with 2 megawatt hour battery, and that's in Cambodia. So coming back to remote management, super critical. We can build the best microgrid, the most optimal design, but if we don't have anything to ensure that it's running optimally for next 20 years, you are not going to get your return, right? And for that, Canopy Power has developed Hornbill, which is a microgrid asset management platform. Just using this platform, we can help our customers to monitor, manage the microgrids. It has three pillars: data acquisition. We have a hardware which sits on site. If you have data, you can just send to us through API, and the information then can go to the cloud, where you can visualize it using Hornbill portal. And the third part is data analytics, where the data we have used is used for continuous optimization. And if you want to know more about this, we can't cover all of that today. However, I'm going to show you guys a very quick demo in 5 minutes. Then it'll take 35 minutes, but let's get a glimpse of it. So let me share my screen. Okay. Daniel, I'm getting an error. You have to stop sharing the screen. Okay, now I'll do it. Okay, great. I hope you guys can see this portal. And once somebody logs in, they see this portal. It's a demo account. It's a simulated data, but it's a quick overview. You can see how your microgrid is doing. In this case, solar is taking care of load, and the battery is charging. Actually, it's pretty much fully charged. Let's say your engineer wants to go in details. Again, I won't be able to show all the things, but I'm just going to cover certain. And let's look at yesterday so that we can see the whole 24-hour of that. I'm going to turn off certain things. So in this demo resort, this is the load curve. This is the 24-hour load curve. If I superimpose solar on that, you see excess solar. And as we explained, this excess solar is going to go in the batteries. There you go. Anything below line 0, when the orange curve is line 0, below line 0, that means it's charging. And when it's above, it's discharging. And maybe we can superimpose genset also. So here you go. So this shows the last 24 hours performance. You can see that most of the hours, the genset was off, the blue color. And it ran only at night when the batteries were fully discharged. This system is designed in such a way that you are getting this resort is supposed to get about 60% of their renewable of their load taken care of by renewables. So this gives you an overview. It gives historical data. Let's say you want to go in the details and you want to see how the batteries are doing. You can go in the monitoring data for batteries, and you have information about how the inverter 1 is doing, 2, 3, how's the state of charge going up and down, battery current levels and all that. Again, this data is very useful to ensure the health of the system. May not be used by the ops manager or the engineering team on our side as well as the customer side. They use this a lot. You may want to see how the load is doing, so let's say this we have divided the load into 3-4 different categories. They have something called staff room, and you see the load going up and down. This is a great tool for the operations manager to ensure that the load is at the lowest, because remember, if your load is high, you are going to run it using diesel, because solar is going to be finite. So this is some information about monitoring data. You can run reports. You can download data using the data export tool if you want to go deep in the details of that. I want to touch base on something, a new feature we have developed, which is about data analytics for batteries. Batteries are the most expensive capex item. So you want to know how your batteries are doing. In most of the cases today, this information is not provided. Customers, even us, if we are providing O&M details, we cannot see how the battery's health is. That's why we developed this tool. Click on that, and I'm just going to show you certain things like here, certain metrics like what is the battery life. Okay, 6 months. the number of cycles completed. The end of life value is supposed to be 3000. This comes from the battery warranty. We are done 170 in 6 months. Okay, this tells me that the battery will go on for 7-8 years if we stick to this regime. Temperature is very important for battery performance. So the temperature is tracked here against the threshold values. And the battery capacity, battery degrades like anything else. So you want to know at any given moment, what is the battery capacity based on the warranty curve. Here it is 28 kilowatt hours, and how's your system do is 28.7 kilowatt hours. There are several other features. We'll be happy to show those to you one-on-one because it takes some time. We also have a tool for incidents to track the incidents if there are any issues, and those are very important towards operation and maintenance of the system. But here is the good thing about Hornbill. Hornbill is a two-way system. It's not just a one-way system sending data out. Sitting here in Singapore, we can interact with all our microgrids, doesn't matter where they are. So a lot of O&M stuff, which is changing the set points of different hardware, or turning things on and off, can be done remotely. So what we have seen over last 3-4 years is 80% of all these items we can do remotely sitting here in Singapore. We are adding more and more tools so that we can even do more. But what that means is less travel, faster response, and because of that, our O&M packages we provide to our customers, they are also cheaper than whatever you can get in the market. So this is just a glimpse of Hornbill portal. There's a Hornbill data analytics service, which is a separate thing. Very happy to show it to those who are interested. So I'm going to stop, and Daniel can go back to the presentation. So what I want to show is I just want to give an example of the this particular resort. Hold on, the slides are coming up. Okay, let's move on to the next one. Yeah, so Telunas Resort is one of our customers. They were very kind enough to allow us to show their case study. This is the resort, and you see that there are solar panels, some ground mount, some rooftop. They like anybody else. They faced high energy cost, 100% diesel. Energy security was a problem getting the diesel from mainland. So that's the logistic burden. They're an eco resort, but running diesel, so they know that there was an environmental impact, carbon emissions and all that. So we added a 100+ kilowatt hour system there, kilowatt peak solar system there, and we had taken them to about 50-55% renewable energy penetration. On the days like this COVID-19 lockdown, when the resort is actually closed, but they still need electricity. So for last 2 months or so, they have not started their genset at all. The system completely works PV batteries because the load is less. And next year we are planning to actually double up their capacity to take them to 85-90% of renewable energy penetration. So just wanted to give you a glimpse how the typical system would look. The idea always is to ensure that we design the system in such a way that the cost of electricity is at the minimum. Yeah, because that's what we are driving. Yes, emission reduction, all the environmental impact is going to come with it, but we understand that the cost parameter is also very critical. So that's the end of it. We are remote microgrid experts, and our goal is to help our customers to make a seamless transition towards sustainable, clean electricity. And doesn't matter where you are. We have done projects at very remote locations, so we understand the pain, and we also understand the challenges of doing that. So this pause because of COVID-19 is actually an opportunity for all of us. Those who are interested, can contact us anytime, and we can provide you information about how you can do the transition, including we can give you the technical proposals, costing, financing options. And whenever you're ready, whenever you reopen, whenever you're ready, just let us know if you would like to execute. So those who are interested, feel free to contact using our website or just send email at contact@canopypower.com. And now, Daniel, we can start the Q&A.
Yeah, I think Andre is going to paste a link. So if you're interested in getting a proposal, Andre is going to paste a link into the chat, so you can just go straight to that, and it's going to direct you to a small questionnaire where we'll get the information, and then we'll provide you a proposal. Yeah, so Q&A, let's do this. So we've got 5 questions so far. First one, as per your comment on price trend of lithium batteries, which will decrease from time to time, lithium ion is mainly dependent on lithium metals, which are considered less abundant on Earth. As lithium is getting less and less, the cost of lithium ion might be going up significantly. May I know your view towards this issue? Yeah. So I read that, I've had a think about it, and I think I've got an answer for that one. So I totally share your view that lithium metals like cobalt, lithium are restricted. They're not everywhere. They're not like oil, and they're not like other metals. But so far, yeah, we have seen lithium battery trends. Prices are going down. We haven't really seen any sustained increase in price yet. We're buying batteries right now for much less than we were a year ago. About 20% less than we were a year ago. So we're still seeing a trend downwards. But as I mentioned before, we are technology agnostic. So it's not like we're married to lithium-ion batteries. It's just that lithium-ion batteries are the best solution right now. There are other battery solutions out there which we're well aware of. Vanadium redox flow is one. And long term, we think hydrogen is another option for energy storage, where you have electrolyzers and the like on site. So while lithium is our go-to solution right now, it's certainly not something that we're married to, and we'll certainly look at other solutions if the commercials look good. And then there's also other things. You know, some of our sites are so remote that getting other technologies there is a troublesome thing. So even if the price doesn't go higher, it might be that lithium is still the right solution. So we look at everything on a case-by-case basis. But I totally agree, and yeah, we keep an eye on this. And we're hoping that lithium doesn't rise, but if it does, we'll look at other technologies. Second question, why is stability reduced when the hybrid system, diesel with PV, I guess, without batteries? So why is stability reduced? Okay, so my comment is that it's potentially reduced. If it's designed properly, that risk is very, very low, that stability is reduced. But we often see systems that aren't designed properly, where the PV is oversized. And we also see systems where the controller isn't actually the right controller to do the job. So the PV might be generating more than the load, and the generator is still on, which means the generator is almost being damaged. Its life is being severely impacted. But if it's properly designed with the right controllers, and the PV isn't ever more than 20–30% of the load, it shouldn't have an impact on stability. Okay, do you have any reference projects in the Philippines? That's easy. No, we don't.
Yeah, what we have is we have been working with several developers. We have provided engineering services there. In Philippines today, we have a couple of deals under negotiations, which are obviously on hold right now. But from the project point of view, we don't have any references in Philippines yet.
Yeah. All of our projects so far in Indonesia, we've got 5 microgrids in Indonesia. We have 1 in Malaysia, which is just being commissioned, COVID pending, and 1 in Myanmar, which was commissioned 2 years ago, and then we're building 1 in Cambodia. the moment.
Yeah.
So, anything else to add, Sujay?
No. But I'll take the next question from Lekha
Sure.
about ROI, and also combine that question with Pankaj. So generally, the ROI when the diesel prices are not very high, not very low, when the diesel prices, the oil prices were something like $50 a barrel, we saw that the ROI was anything between 4 to 7 years for the microgrids. Okay, but you need to put that in perspective with the lifetime of these systems. They have 20 to 25 years of lifetime. And yes, when we do this calculation, we do consider the replacement cost of certain solar items like inverters, also the battery systems and all that. When the financing is provided, and if it's less than say 10 years, after which you may have to change the batteries, the customer has an option to get that part financed also, or if they want, they can do it themselves. But sometimes for that, we have seen customers say that if it's needed, I'll do it myself, because the prices are still going down. And it's not that easy to actually guess the price 10, 12 years down the line.
So the ROI? Did you answer that one, Sujay?
Yeah, I mean, in the payback period point of view,
Yeah.
the ROI is like 4 to 7 years. Yeah.
Yep. Right. That's for a hybrid system with batteries, and it can be 2.5 years if you don't have a battery. It's just
Correct.
Okay. How do you see the solution being competitive relative to diesel with oil prices going down? Yeah. So that's something that's very, very recent. We haven't really had a chance to look at that in detail. We have seen oil prices crash in the past, and it doesn't really have a huge impact on diesel price in the short term. If oil does stay at this level for 6 months to a year or more, I believe diesel will start to come down. That obviously means that diesel is more competitive relative to renewable energy. However, most of our customers so far, and the ones we talk to, they're driven not only by cost savings, they're driven by a need or a desire to be more eco-friendly, to have the sustainability credentials. So we don't think it's going to completely change the game if oil stays low. I would say, in terms of statistics, it will reduce our market. The people that are only cost-driven will have a reduced kind of like reason to make the change, but it's not the be-all and end-all, I don't think. Next question: what is the impact of the low? Okay, I think that's the same, right? That one. I hope I answered that. Also, do you consider the cost of battery, which generally takes place after 10 years, as this needs to be paid by the customer? Yes, we do, yes. It depends how it's financed. But yeah, the financier has to take into account that. So when we're doing our long-term project cost modeling, that's taken into account, and it's included in the lease price or the PPA price. If a customer's buying CapEx themselves, then we make sure that they're aware, and they have to they see the warranty terms of the battery. And most batteries give warranties that are performance warranties up to 10 years now. So the customers are well aware that they need to replace that battery after 10 years. Or they can choose to keep it running at a lower capacity after that if they want. Okay, Sujay, do you want to do the next one?
Yes.
Loads of questions coming in. Hold on. What's the next one?
I read the questions, and there is a group of questions about O&M. So let me try to answer them together.
Okay.
O&M is critical, operation and maintenance for these systems, like anything else, to ensure that we get the maximum out of them. Remoteness adds some more complexity to that, and that's why Hornbill system plays an important role of remote monitoring management using the platform. But yes, we have O&M packages. So if we have built the project, as an industry standard, we provide 1 year of DLP, defect liability period. After that, our customers have an option, and most of them go for that, to sign O&M contract with us. And there are different flavors to that, but typical contract where our technicians will visit the site twice a year, and they can check things, they can fix things. Plus, we provide the remote support. In some cases, customers have chosen option where two visits per year plus any ad hoc visits. So the pricing changes accordingly. That's how we provide the O&M services.
Oh, whoops. I was trying to answer a question with typing, but it disappeared. Sorry about that. The question was how much space is required for 1 megawatt, and the answer is 1 hectare roughly. So 100 meters by 100 meters of land. Quickly run through these. So DoD considered for such projects, we typically run our batteries down to about 20% normally. It really depends on the battery and the recommendations of the supplier. Some others are quite happy to go down to 0, but it depends how the manufacturer actually does their actual state of charge metrics. Sometimes they actually have, when they say 0 state of charge, they actually have some left over anyway, so it's still safe. But yeah, 20% typical. So the top one, let's just do this one. Would a microgrid system with only PV and battery provide better savings in the long term, particularly for a new installation? So without a genset, it's not practical. In a short answer, it's not practical because you'd need hugely oversized PV and hugely oversized battery to cater for those periods like the monsoon season where you don't get any real sunlight for 3 or 4 days in a row. You'd have to have such a big system and it would cost so much that it wouldn't be practical. So it's always best to have genset there for those 10%. We can practically get to 85, 90 without going too crazy on the price. But going beyond 90% is just not practical at this stage. That's those two. Sujay, did you ask the one about humidity, O&M?
Yeah, I saw that. Okay, yeah, so it's again coming back to O&M, humidity, that's fact of life for us here in this region. Yes, so you have to take care of certain things. Some battery suppliers or some battery brands need air-conditioned room because of humidity. So if that one is chosen, then you have to provide that. Other than that, we use the components which are certified for humid areas, also for salt mist conditions. Basically, many of our installations are very close to the sea, but we use components which have certification for salt mist conditions.
Okay.
Yeah. Okay. One more question here from Mark. Do you provide full PV system as opposed to hybrid? Mark, yes, we do. Sometimes we have provided PV systems which are connected to diesel gensets or to the power grid. Canopy Power's focus is on microgrid. So we are not doing the systems which are, say, in the city like Jakarta, Manila, or Singapore, which are grid connected, because you may know that there are several other companies who are providing that service. So our niche is into the mainly for diesel replacement or helping people out if they are connected to power grid. They can be just PV system, but the complementary source many times, and most of the times in our case, is not the stable grid because we are not active there.
All right. think generally, so from Pankaj, generally PV PPA 25 years. Yep, that's right. Is there a reason for your project to be 10 years? Firstly, we're talking about lease. When we say 10 years, we're talking about a lease finance, not PPA. PPAs would still be 20 or 25 years usually. But for our projects, lease works better because typically the customer continues to own the genset. So they continue to O&M the genset, they provide the fuel for the genset. And the financier owns the PV and the battery system. So a PPA is quite complicated in that scenario. So we favor equipment leases because you never know when the genset might be adding charge to the battery, for example, and the customer might be paying for that and getting no benefit, things like that. So lease is just a better way of doing it, and it ends up with the interest rates, it ends up being a better and more affordable deal for the customer.
Yeah. Great. We have crossed the 1 hour limit. So there are certain questions which were not fully replied, or what we'll do is we will send you an email with the answer. Okay. But if you have more questions, please contact us at contact@canopypower.com or through LinkedIn or whichever whatever works for you. Okay. Thank you very much, everybody, for your time today. I hope you learned something about microgrids. And if you want us to go in detail about certain things, please let us know, because we are planning to have more webinars maybe once every month. So we are curious to know what topics you guys can provide us. Thank you very much.
Thank you.
Goodbye.
Goodbye.